Jai Hind everyone. Today I am going to talk about the state space analysis. So the topic which I am going to cover in this lecture are the how to obtain any state model if a transfer function is given to us, or how to obtain a transfer function if state model is given to us, or otherwise in this case we have two cases in that if we have to find out the state model from transfer function. First one is if we having only the constant term in the numerator, and the second case is if the polynomial function of s is present in the numerator. And the second topic is how to obtain the transfer function from the state model, right? First topic is how to obtain the state model from the transfer function, and the second one is how to obtain the transfer function from the state model. And based on these topics I will discuss example in this lecture. So the two types of transfer function based upon the terms present in the numerator will be the transfer function having a constant term in the numerator and the transfer function having a polynomial function of s in the numerator. So I am going to discuss one by one about these two transfer function. Before starting for this, I would like to tell you about the state space model, right? So these are the two equation for the state space model. X dot is equals to ax plus bu and y is equals to cx plus du, right? Here u is the input and x are the states of the system and y is the output of the system. This x dot, this equation is known as the state equation, and this equation will be known as the output equation, right? And combined it will make the state model, right? So how to obtain the transfer function by using from this state model, right? The first case is when I am having a constant term, that is b naught, in the transfer function. As we know, for any system, see, this is the system in which there are n number of inputs, let's say u1, u2 up to un, right? And this is the system, and there are n number of output y1, y2 up to yn, right? And corresponding in intermediate there are many states x1, x2, x3 up to xn, right? For this type of system, how to obtain the state model, that I have told you, that will be the x dot is equals to ax plus bu and y is equals to cx plus du. Now if I am having a single input single output system, then the output of the system, that is y upon input of the system, is u, and the Laplace transform of this, that is ys upon us, will be called as the transfer function of the system. Now the transfer function is given to us, that is b naught upon s raised to the power n plus an minus 1 sn minus 1 plus up to so on. It will goes to a1s plus a naught. Now how to obtain the state model from this equation? First of all, when ys upon us is given, then split ys upon us into two terms. Let's say ys upon xs into xs upon us, right? Now take the xs upon us, xs upon us will be the constant along with the denominator, right? That is s raised to the power n plus an minus k1 into sn minus k1 plus up to so on till a1s plus a naught, right? And take ys upon xs will be the constant term in the numerator, that is b naught, right? So when I am taking solving this case, and then I will solve this case, okay? So here you can see, go for the cross multiplication, then you will get us will be equals to s raised to the power n into xs plus an minus 1 into s raised to the power n minus k1 into xs up to so on till a1 s into xs plus a naught into xs. Okay, now take inverse Laplace transform of this equation. So you'll get ut will be equals to nth time differentiation of xt plus an minus 1 is the constant here, and dn minus k1 of xt upon dt n minus k1 up to so on till a1 dx by dt plus a naught into xt. Okay, a naught into xt, right? Now let xt here will be equals to x1. Okay, now let xt here will be equals to x1, then x1 dot of t will be equals to x2, and then x2 dot will be equals to x3 up to so on till xn minus k1 dot will be equals to xn. So xn dot now will be equals to, we can take it from the previous equation, from this equation this will be the xn dot will be equals to, from I am writing the values here in this equation. First of all, ut will be equals to xn dot. Okay, so I am writing it, ut will be equals to xn dot plus, this is an minus k1 into dn minus k1 x will be equals to, this is xn. So this is an minus k1 into x1, right? Sorry, xn, then an minus k2 into x. This is x x2, sorry, right? This is total is n, then x2, right? Up to so on till a1 of x2 plus. What I am doing here is just a minute. I am taking the common term with this, okay, and I am writing it here as 1 and take it like b naught over here. Okay, so this will be b naught into ut. Okay, so this b naught into ut will be equals to like this, and up to so on till this is a1 into x2 plus a naught into x1. Okay, so from here I will get the value of xn dot, which will be equals to b naught ut minus an minus k1 into xn minus an minus k2 into x2. Okay, up to minus up to so on minus a1 x2, okay, minus a naught into x1. Okay, so then I can make the state model from here only. Just a second. Okay, so फिर I am getting here x1 dot, this is same as this. Okay, x1 dot, x2 dot, x3 dot up to xn dot will be equals to, this will be my matrix A, and this will be x1, x2, x3 up to xn ax plus bu, right? So here I am having b into ut, right? So x1 dot here you can get it from here will be equals to x2. So I can write it 0, 1 up to n at time 0, right? Then x2 dot is equals to x3. So I will write 0, 0, 1, 0, 0 up to last tak x2. Similarly, x3 dot will be equals to x2, x4. So here 0, 0 up to last tak xn. SSA, and then I am writing the value of xn dot, which will be equals to, here this is x1, x2, x2 dot. In all these terms we have the value of ut will be equals to 0. So I am writing here as 0. And now xn dot ke liye the value is b naught ut, that means up to 0 last value will be b naught into ut minus of, we'll take it from here, minus of a naught into x1, then minus of a1 into x2, then minus of a2 into x3 up to so on, and at last I am having an minus k1 into sorry, this is xn, so this is xn minus 1, right? So an minus k1 into xn, and this is an minus k last term is an minus k2 and this is an minus 1, right? So this will be the state model, that is x dot is equals to ax plus bu, right? So this will be the matrix A here and this will be the matrix B here. Okay, now finding the output equation. Output equation I have taken here is ys upon xs is equals to 1, as I am left with. So here ys upon xs will be equals to 1. So again cross multiplying this term, then I am getting ys is equals to xs. And what is xs? Where that is xs is equals to x1 हमने last माना. So ys will be equals to x1. Sorry, yt is equals to x1, right? Okay, so I can write yt is equals to c into x1, x2, x3 up to xn and plus 0 d into u, right? So this term is 0 here, क्योंकि इसमें y is equals to x1 ही हो गया, तो 1 0 0 up to so on till 0. So this will be the state model from the transfer function if I am having a numerator constant term in the numerator, right? So this will be y is equals to cx plus du, right? Here d is 0 and this is the c. Okay. Now if I am having a polynomial function of s in the numerator, then again I am splitting ys upon us into two terms, ys upon xs, right? And xs, this is multiplication, xs upon us, right? Now again here I am taking xs upon us will be equals to constant upon denominator, right? And the s polynomial in the numerator will be taken with the ys upon xs. So the term will be sn plus an minus k1 into sn minus k1 plus up to so on plus a1s plus a naught, right? And here ys upon xs will be equals to bn sn plus bn minus k1 sn minus k1 up to so on plus b1s plus, so I am taking one at a time. First I am solving this, then I'll go for that. Okay, so again going for the cross multiplication, I am getting sn into xs plus an minus k1 into sn minus 1 into xs plus sn minus k2 into an minus k2 into xs up to so on, and this will be a1s into xs plus a naught into xs will be equals to simple us. Now taking inverse Laplace transform of the above equation, we'll get the equation in terms of time domain, right? So this will be differentiation of xt in nth time, right, plus the constant an minus k1 differentiation of xt n minus k1 times, ठीक है, and up to so on, and at last I am having a1 into dx by dt plus a naught into xt will be equals to ut, right? Now again I can assume the value of xt, let xt will be equals to x1t, let xt is equals to x1, then x1 dot will be equals to x2, x2 dot will be equals to x3 up to so on, and xn minus k1 dot will be equals to xn. Now what will be the value of xn dot? So in this equation I am putting the value of xn dot will be equals to ut minus all these terms. So I am writing it directly, xn dot will be equals to ut minus, this is an minus k1 into an minus k1 into xn, then minus of an minus k2 into xn, this is xn minus k1 minus up to so on, and here I am getting a1 into x2 and minus of a naught into x1. Okay, this is the final equation. So I can write again, draw the state model from this x1 dot x2 dot up to so on till xn dot will be equals to what? A into x1, x2, x3 up to so on till xn, and this is the term b into ut, right? So x1 dot here is again equals to x2, so I'll write 0 1 0 0 till 0. x1 dot 2 dot is equals to x3, so 0 0 1 0 up to so on till 0. Again 0 0 0 1 0 0 up to so on till 0, and at last xn dot will be equal to, here again I am having 0 0 because there is no ut term in these equations, and at last xn dot will be equals to ut, that means 1 times of ut minus of, this is a naught, then minus of a naught into x1 minus a1 into x2 up to so on, and I am having at last minus of a n minus k2 and minus of a n minus k1 into xn. So this will be the a x dot is equals to ax plus bu. So this term will be the b matrix, right? Now solving the other part to get the output equation, that is ys upon xs will be equals to, okay, here I have already written, so let me use it. Ys upon xs will be equals to bn into sn plus bn into sn plus bn minus k1 into sn minus k1 up to so on, and the last term is b1 into s and b naught, b1 into s plus minus b naught, sorry ये plus में चल रहा है, right? Let me check once. Okay, b1 into s or into b naught, right? Okay, now again doing the cross multiplication. Okay, so upon में तो इनके नीचे 1 है ना, so ys will be equals to bn sn into xs plus bn minus k1 is a constant, sn minus k1 into xs up to so on, and I am getting this b1 into s into xs plus b naught into xs, right? Now let again taking inverse Laplace transform of the above equation, what I am getting is y is equals to yt is equals to actually bn into dnx of t by dtn plus bn minus 1 is a constant, dn minus k1 into xt upon dt n minus k1 up to so on, and this is will be v1 into dx by dt plus b naught into xt, right? और हमने पहले क्या माना था, let xt is equals to x1, हम previous slide में मान चुके हैं, वही same. Then x1 dot is equals to x2, then x2 dot is equals to x3 up to so on till xn dot will be equals to xn minus 1 dot will be equals to xn. So here I am getting the value of, this is dn minus, okay, this is xn, okay. So yt will be equals to, I can write it as yt will be equals to bn, and this should be what this should be? This should be xn dot plus bn minus k1, this is xn plus bn minus k2 into xn minus k1, ठीक है, up to so on, और यहाँ आ गया हमारे पास b1 into x1, sorry, b1 into x2 and plus b naught into x1. Now what to do with this x naught? I'll put the value of x naught from the previous slide in this equation, that is the value of this equation. This equation will be put in that output equation. Xn dot will be equals to ut minus an minus 1 into xn. So I'll put here yt is equals to bn, और यहाँ क्या आ जाएगा ut माइनस व्हाट वाज दैट an माइनस के 1 xn an minus के 1 into xn minus of I think an minus के 2 into xn minus 1, right, up to so on till minus of a1 x2, up to so on till minus of a1 x2 minus of a0 x1. Rest all the terms will be same, plus bn minus के 1 xn plus bn minus के 2 xn minus के 1 up to so on till b1 x2 and plus b0 x1. So what I'll do, I'll simplify these two terms, like that means xn वाला term एक मेरे पास ये रहा, see I have two terms of xn, एक term ये रहा bn minus के, sorry एक term मेरे पास ये रहा और एक term ये रहा s, तो I can take bn as common and I simplify these constant values, right? So yt will be equals to, okay, I have nowhere space, so I am using it here, okay. So this is written already यहाँ, right? जो मैंने अभी लिखा है ये यहाँ as it is लिखा है, right? तो यहाँ पे मैं आपको कॉमन लेके दिखा देती हूँ. So y will be equals to यहाँ पर x1 अगर हम कॉमन ले रहे हैं तो क्या हो जाएगा उधर से b0 यहाँ से और यहाँ से क्या हो जाएगा bn माइनस a0 इंटू bn, राइट. देन प्लस मैंने x2 कॉमन लिया, इधर से मुझे मिला b1 और इधर से मुझे मिला माइनस ऑफ bn इंटू a1, राइट, अप टू सो ऑन. एंड मैंने लिया देन xn कॉमन एंड आई विल गेटिंग हियर bn माइनस के 1 minus of bn into an minus k1, right, and last में bn into u will be the constant, right. So यहाँ से I can make y is equals to c into x1 x2 x3 up to xn, right, plus u, ठीक. तो यहाँ पे y is equals to, ये मेरा बनेगा 1/nth टाइम का मैट्रिक्स और ये है n इंटू 1 का, ये 1/n का मैट्रिक्स बनेगा. तो मैं यहाँ फर्स्ट टर्म लिखूंगी b0 इंटू माइनस a0 bn, देन अगला टर्म मेरा आ रहा है b1 माइनस bn इंटू a1 अप टू सो ऑन, और लास्ट में मेरे टर्म्स आएंगे xn के लिए. ओके, दिस विल बी माय लास्ट टर्म फॉर द xn हेयर, ठीक. एंड ut इज द हेयर bn into ut. Okay, so this will be 1/1 की मैट्रिक्स होगी. okay, 1/n की मैट्रिक्स होगी. just a minute 1/, okay, sorry, this will be this into 0, sorry, this will be 0 0 0 0, right. y is equals to this into, then this 0 into, as I have taken it y, okay, मैं इसको y ले रही हूँ और इधर x1 x2, तो ये 1/n टाइम्स होनी चाहिए और ये n/1 होनी चाहिए. तो ये करेक्ट है, दिस इज करेक्ट. ओके, दिस इज करेक्ट. ओके, दिस टर्म विल बी माय सेकंड टर्म. तो भी मेरे को 1/1 की मैट्रिक्स मिल जाएगी ना इसको कैंसिल करके, तो हाँ ठीक है, करेक्ट है. ये 1/n की मैट्रिक्स होगी, n/1 की मैट्रिक्स है, करेक्ट. सो यहाँ पर मेरे पास आएंगे द टर्म्स. अगेन लेट मी राइट द टर्म्स हियर. इसको मैं थोड़ा सा, सो हियर y विल बी इक्वल्स टू b0 माइनस a0 bn and then second term b1 minus bn a1 up to so on, and last term मेरे पास आएगा यहाँ bn minus k1 minus of bn an minus k1, and this will be my matrix, this into this will be 1/n times matrix and this is n/1, और ये मेरी क्या होगी 1/1 bn into u. So this is y, this is the c and this is the matrix D. Okay, so this is a state model when I am having a polynomial function of s in the numerator. So let's go for one of the example. This is the example. So we have to find out the state space model of the system which is having a transfer function of 1 upon s square plus s plus 1. So what I'll do is ys upon xs upon into xs upon us will be equals to 1 upon s square plus s plus 1, right? So I'll take ys upon xs is equals to 1 and xs upon us will be equals to 1 upon s square plus s plus 1. So first I'll solve this. So by doing the cross multiplication, the s square into xs plus s into xs plus xs will be equals to us. Okay, so taking inverse Laplace transform of this equation, what is this? This will be d2 xt by dt2 plus dx by dt plus xt will be equals to ut. Okay, so let xt will be equals to x1. Let xt will be equals to x1. So x1 dot will be equals to x2, and now from here x2 dot will be equals to, from here I can write x2 dot will be equals to ut minus, this will be x1 minus, this is x2. So I can draw the state model, I can write out the state model which will be equals to x1 dot, x2 dot will be equals to, here x1 dot is equals to 0 1 and here I am getting minus 1 minus 1. Okay, this will be x1 x2 प्लस b इंटू u था ना इसमें तो 0 आ रहा है और यहाँ क्या टर्म आ रहा है हमारा, दिस इज 1, कोफिशिएंट इज 1 हियर, सो आई एम राइटिंग हियर 1. ठीक है, एंड नाउ सेकंड वन इज दिस ys इज इक्वल्स टू ys अपॉन xs will be equals to 1. So again going for the cross multiplication I am getting ys is equals to xs. So since I have taken xs is equals to x1, so taking Laplace inverse Laplace transform of this will be getting yt is equals to xt, and I have taken xt is equals to x1. So y will be equals to this x1 x2, this will be the 1 0. ठीक है, d, so this is the matrix C here, this is the matrix A here, this is the matrix B, and d will be equals to 0 here. ठीक है. Now how to obtain the transfer function of the state model? Since I have the state model as x dot is equals to ax plus bu and y is equals to cx plus du, right? So taking the Laplace transform of what the equation? Here I am getting s of xs minus x0, okay, plus is equals to a into xs, because a b c d are the constant matrix, right? axs plus b into us. Similarly इसका Laplace transform लेंगे तो I am getting ys is equals to c of xs plus d of us. Okay, now see this equation. Here I can take xs as common, but if I am writing it as s into xs minus a into xs is equals to, since for the transfer function the initial value of the initial condition is equals to 0, so I am taking here is at xs is equals to 0. ठीक है, initial condition is 0 for the transfer function. ठीक, तो ये बचा, and you know this s is the operator which is used in the Laplace transform, and a is the matrix here, right? So I'll multiply this operator s with the identity matrix which is having a same order as that of the constant matrix A, so that I can take make the order of the matrix same. Okay, so I can take common xs and I am writing directly si minus a, sorry, into xs will be equals to b into us. Now pre-multiplying both side by si minus a inverse. Take both sides by si minus a का inverse. So what I am getting here, si minus a inverse into Si minus A into XS is equals to Si minus A inverse into B into US, right? So this is equals to 1, right? So XS here I am getting is Si minus A inverse into B into US, right? Now put the equation of value of this XS in this equation. Since the, so I am getting Ys is equals to C into Si minus A ka inverse into B into US, right, plus D into US. And since US is the input to the system and Ys is the output to the system, and transfer function is the ratio of output to the input, so I can take US common from the above equation and I can write the value of transfer function will be equals to C into Si minus A inverse into B plus D. So this is the transfer function from the state model. Now solving one of the question given here, we have to calculate the transfer function of the system which is represented in this state model. So from this state model I can conclude that x dot is equals to, this is the matrix A x plus B u y is equals to Cx, right? So before finding the transfer function, first of all I have to find out the Si minus A ka inverse. So okay, सबसे पहले I have to take Si minus A. So S is the operator, since A is the matrix of the order 2 by 2, so I'll take identity matrix of the order 2 by 2. Si minus A, okay, this is minus 1, 1, 0, so it is coming out to be S plus 1 into plus 1, and this is again minus 1, and this is S, okay. Now taking the determinant of Si minus A, because the inverse of Si minus A will be the adjoint of Si minus A upon the determinant of Si minus A. So determinant will be S into S plus 1 minus of minus 1 into 1, which will be equals to S square plus S plus 1. So this is the determinant. Now to find out, see, I have to find out the transfer function. Let me write down the formula for the transfer function here. C into Si minus A inverse into B. So first of all I am working on it, that is Si minus A inverse. So the formula for the Si minus A inverse is the adjoint of Si minus A upon the determinant of Si minus A. So adjoint हमारा ये, determinant हमारा ये आ गया. Now to find out the determinant adjoint of Si minus A, I am working on it here. Cofactor of C11 will be S, and C12 will be equals to minus of minus 1, and C21 will be equals to minus of 21, okay, 1, and C22 will be equals to S plus 1, ठीक है. तो Si minus A का इन्वर्स हमारा क्या आ जाएगा, एडजॉइंट हमारे ये आ गया, इसका ट्रांसपोज हम लिखेंगे यहाँ पर. सो दी Si ये आ रहा है हमारा डायरेक्ट C इंटू Si माइनस A का इन्वर्स इंटू B. अब आप इसको अगर हम मल्टीप्लाई करते हैं तो दिस इंटू दिस, ये 1 अपॉन S स्क्वायर प्लस S प्लस 1 तो हम कॉमन ले लेते हैं. 0 और 1 है हमारे पास, और इसको सॉल्व करके S माइनस 1 1 और S प्लस 1 है हमारे पास इधर, और इधर है 1 0, राइट. तो पहले हम इसका मल्टीप्लिकेशन करेंगे. 1 इंटू 2 है, 1 रो 2 कॉलम्स, और ये 2 बाई 2 है, ठीक है. अब इसको हटाते हैं और ये कैंसिल आउट करके हमारे पास क्या आएगा, 1 बाई 2 का ही आएगा अगेन. सो ये दिस इज 1 बाई S स्क्वायर प्लस S प्लस 1, और ये क्या हो जाएगा, दिस इंटू दिस, दैट मीन्स 1, एंड दिस इंटू दिस विल बी इक्वल्स टू S प्लस 1. तो ये क्या बन गई, 1 बाई 2 की मैट्रिक्स बन गई इंटू B. ये हो गया, ये कितना है 2 बाई 1 की, तो 1 बाई 1 आएगा अगेन सॉल्व करके. सो दिस विल बी 1 बाई S स्क्वायर प्लस S प्लस 1, मैंने कॉमन लिया हुआ है, डिटर्मिनेंट बाहर ही, और हम यहाँ पर अगर इसको मल्टीप्लाई करते हैं तो या तो 1 ही बचा है. तो द ट्रांसफर फंक्शन, वैल्यू ऑफ ट्रांसफर फंक्शन विल बी इक्वल्स टू 1 अपॉन S स्क्वायर प्लस S प्लस 1. दिस विल बी द ट्रांसफर फंक्शन. So you have to do nothing, only you have to find out, you have to just go through the matrix multiplication very carefully, and you have to simply learn the formula for the transfer function and nothing else. So that's all for today's lecture. Thank you so much.